No, because it'll take too long.
No, well, I'll do it fast. You ready? So today was the first year bill payment, and I asked her for an extension. She said I have to get paid next week, so I'm excited because I don't have to give up my paycheck that I just got.
That was quick.
Do you want to have a job?
Okay, here we go. What is the acceleration when t equals 5?
T equals 5. It's going to be at 5.
Negative
So-
5 over
Negative 5.
squared.
Yes, we did that.
Well, we didn't actually finish it.
I said negative 5, and I did.
So anyways, at 5, it's on this line. So we just have to find the slope of this line.
Down 5 over 4.
So we can do that by just taking
2.
those points, which are, this point is 4, 5,
Oh.
and this point is 6, 0.
You made that mistake last week. That's all I knew.
And we can do, let's see, 0 minus 5
Negative 5.
over 6 minus 4, which is negative 5 over 2. So that's negative 5 over 2 feet per second squared. Woot woot. Yay! Okay, C. What is the net distance from the particle distance, the particle travels from t equals 0 to t equals 10. So we do include negatives and whatnot. So from 0 to 10, that's the whole thing.
So we would just subtract the little bitty triangle.
That's right.
Yes.
Did we do? No, we didn't do the area of this.
We did half the trapezoid, so we can, we did half the trapezoid and half the triangle. We did. So we can just multiply by 2.
We didn't do half the trapezoid.
Yes, we did. See, I drew it.
Okay.
I drew it too.
Yes.
Do we have to find the position?
The position?
Yeah, because it's distant.
No, because what we're doing is good question. We are doing basically the integral from 0 to 10 of v of t, which is the area under the curve, which is the position. So that's how we're finding the distance. Which we're just doing it in terms of area. So let me get rid of that. So the area for this trapezoid, we have the height of the trapezoid goes from 0 to 5. So 1/2 times 5. And then the two sides here, we add those together. This one is
6.
on the bottom it's 6, yeah, on the top.
I think it's 4.
Yeah, it's 2.
It's 2.
It is.
So that's 8 times 5,
20.
40 over 2, which is 20.
Or I can just multiply 10 times 2. That is
So the area of the big blue shape is 20. Now the area of pink shape. Here. Area of that is base times height divided by 2. The base is 1, 2, 3, 4. The height is 2 divided by 2. So that's 4, but it's negative because it's below the x-axis.
So 16.
So when I add those up, it's 16, and that's feet. And that is the net distance. That's the total it actually
The total
travels.
distance is 24.
There you go. That's what the next one is talking about. The total distance, so 0 to 10 of the absolute value of v of t dt are just those two both being positive. So I make that pink one up here the positive version of it. So like you said, it's just 20 plus 4, so it's 24 feet. All right. Wait. Okay, so next page we have a table. And this table shows the velocity. And it's in meters per second. Of a particle moving along the x-axis. Okay, what does the value of 0 to 18, the interval 0 to 18 of the velocity represent?
How fast it's moving.
Okay, that would be if we just did velocity. Velocity is how fast.
So this is where they are.
Okay.
This is position. Right?
It's how far a particle moves at what second. No. Yes.
Where each particle moves at what second?
Yeah, but so if we're doing the whole thing from 0 to 18, that's the what? I heard Wynn say it. Net distance, yes. Represents the net distance the particle travels from 0 to 18 seconds. Okay, using a left Riemann sum of 6 subintervals, so rectangles, 6 rectangles of equal length, estimate the value from 0 to 18 of v of t dt, indicate units of measure. Okay, so I want 6 of them. So we're going to go from
2 each.
2 each, yeah. So 1, 2, 3, 4. Ooh, that's making me dizzy. 5, 6.
That's why I do squares.
They're perfect. They're 3 each.
Yeah, I know, right?
Perfect.
Yes!
What?
The distance between each second is
It's
exactly 3. So you don't have to keep redoing.
Yay! Look at ya!
Guys, I've never seen you so happy about
I know, I'm so excited. So 3 times, now which number in the rectangle
The
do I
left
use? The left one, because it's a left Riemann sum.
Oh, hold on. That makes so much more logic.
Man, if you watched the video, you'd already know that.
Well, the thing is, I did watch the video last night at 2 a.m.
Why are you
Well,
watching
maybe
that?
since it was at 2 a.m., it makes less sense.
Probably. Because I'm sitting there, I'm literally looking at these notes and I'm watching the videos and I'm like, how the freak am I supposed to do this?
With math.
With your brain.
I couldn't even tell you my birthday last night, so.
When's your birthday?
October 22nd.
Yeah.
True crime.
Okay,
The
everybody's
stuff in the middle.
got the 33 meters. See that?
Yeah.
All right.
Stuff in the
How did
middle
we-
equals 11.
So,
Yes.
it's meters because yeah.
Yeah, because it says meters per second.
Wait,
So
that's
we integrate, it gets rid of the seconds, the per second. Okay, a right Riemann sum. Same thing, only this time,
Use the right.
What?
use the right one.
So I gotta start labeling my papers left and right.
What'd you guys get?
I don't know.
You're waiting for me to get it.
Yeah, because I don't have to
It's
put it
okay.
in the calculator.
It's 32.4.
That one wasn't as pretty.
Okay, a midpoint Riemann sum. This time we're only using 3 subintervals.
So I gotta erase my squares.
It's just 3.
Okay, so 1,
So I just do
did
3.
not do that right. 2,
So the distance part is 6.
the distance for each one is 6, which Faith is very excited about.
I was so tired of having to rewrite things and it going off my
I know. This is actually really good practice for tomorrow. Because this is the kind of stuff that's going to be on there.
Oh, I murdered that one. That was easy.
I'm glad for everything right.
So then it's 2.7 plus 1.3 plus 1.7. Oops.
So I might not need to come see you anymore.
Okay.
Maybe.
You just come by if you do, don't if you don't. I'll figure it out if you don't come by.
Or sometimes we both forget that I'm supposed to come see you.
Well, that could happen.
Oh, I don't like the trapezoid.
You
Well, it's
don't?
just half, and then you multiply every side.
I don't like
Okay.
Thank you. So this one has 6 sub-intervals of equal length. So
So I gotta go back and draw more squares.
Yes.
Oh,
Well-
actually, I can just draw squares in front of my squares. Yes.
back to what they were. 1, 2, 3. Ooh, that really does make me dizzy. 4, 5,
Why do you?
6. I don't know.
How'd your son do at the swim meet?
Oh,
He
yeah.
did really good. He got 2 first place,
Whoa.
a second place, a third place, and a fourth place.
How many people were there? Was it a big one?
It was big. Yeah, we had and we as the Jets won the meet.
Yeah. Where'd y'all go?
Pocahontas.
Okay.
We were up against the Dolphins, the Cersei Sharks, the Mountain Home something.
I bet you seals.
Dart Frogs, which is another Jonesboro.
Are they any good?
I have a question.
Yeah.
Why do they compete?
If we only have one pool,
Why
how do we have 2 swim teams?
They do it at the trim gym.
Yep.
don't they?
Dart Frogs have trim gym.
I didn't know we had.
We have
Yeah.
the
Why-
City Pool and St. Bernard's Health and Wellness.
Oh, y'all got 2?
Why do we call it the Jets? That doesn't seem like water.
Because you're fast.
Jets.
Yeah, your jet in the water.
Okay, moving on.
Submarines.
Yeah. Right, we don't want to sink. All right, here we go.
Well, yesterday
So,
I showed on my guy.
trapezoids, since they're the same, I can do it this way. They each have
3/3.
3. So it's 3/2, yes. Are you okay?
No,
I'm
I
on
just showed them.
So then it's the first one plus 2 times the next one plus 2 times the next one plus 2 times the next one plus 2 times the next
Why
one.
are you gonna make a new picture?
When we get erased markers.
Okay, okay. And then it's going to end at 2.1 with just being one of those.
Is it 2 times these all because
You're
they share a
slice.
side?
They share a side because it's the one side of, it's the end of one trapezoid and the beginning of the next one.
Okay. So just
That's why the first and the last one don't have 2 because they're only in one trapezoid.
Okay.
All right. How you feel?
Got this stuff great.
Good. Well, this is stuff that's on the quiz, so that's good. Find the average acceleration of the particle from 3 to 9. For what value of t in the table is this average acceleration approximately equal to v prime of t? Explain your reasoning. So let's start with
2.
average acceleration from 3 to 9. So let's look up here. How do I find the average acceleration from 3 to 9? This is velocity.
Reverse.
Reverse goes back
Never
to,
mind.
The antiderivative of 3.
antiderivative goes to position.
We go forward.
We
The
want
derivative.
acceleration.
There's a derivative.
Just add the 2.
Yeah. It's the derivative, which I can't really do here. So how do I do average
You're
of
gonna
a
go.
Alpha B minus alpha.
slope? We do slope.
Yeah.